Hello. This brief video is intended to demonstrate how the sums of squares are calculated graphically for an analysis of variance. So we're going to start with a very small data set where we have three groups and there's 4 data points within each group. Each group is indicated here by a different color. The first thing we want to do is aggregate the data set and think of it as one large data set. Here's a horizontal line indicating the average for that aggregate data set. So we want to think, how far is every point away from that line? Recalling from our understanding of the standard deviation is the square root of the variance, and the variance is the average of the sums of squares of the deviance of each score. The deviance, again, is how far each value is away from the average. So simply put, we think about the distance of each point from the average, and then we think about the square that would be attached to that distance. And the advantage here is that every value is now positive. What I'm going to do for graphical purposes is take all of these areas, and we're going to break the areas up and put them above in such a way that we collect them all in one place in a horizontal bar. Now, the bar that we have here simply indicates all of the sums of squares represented in one long bar. We'll come back to this image again shortly. Now, if we go back to the fact that we actually have group data, we can think of each group having its own specific average. And we can do a comparable calculation within each group where we ask how far is every value in the group away from its group mean. In a similar fashion, using the deviance scores, we would calculate the sums of squares. And again, I'm going to imagine moving these areas into a long vertical block. So now we have the sums of squares within each group. The next step is a little trickier. Now, what I want to do is I want to think about each group in a way where I imagine that every value in the group is actually just the value of the group mean. So what we noticed is that all the points have fallen onto their respective bars. I want to superimpose on this the average of the aggregate group. Now, if I think about my transformed data set, I can ask how far away are each of these individual points representing the group means from the aggregate mean. Again, we can imagine that deviance represented as the sums of squares, and we can accumulate those sums of squares into their respective portion of the vertical bar that we had accumulated earlier. And what we've actually done is we've actually demonstrated that the sums of squares that we obtain within each group, along with the sums of squares, quote unquote, between each group, where the between comparison is between the group mean and the aggregate mean, this turns out to be the same as the original sums of squares for the aggregate group. This in turn gives us a breakdown for the sums of squares table that we use in the ANOVA analysis. Thank you for listening.